How you doing, guys? I just thought I'd do a quick video on the basic sequence of operation of a boiler. This is the sort of sequence that I used when I started off doing breakdowns. I'm still following this sequence today, with obviously a few extra bits that I've picked up along the way. But if you follow this guide, I mean, it's not going to be 100% correct, or it's not going to be 100% accurate, but it is a basic guide, and it will help you initially on the road to becoming a breakdown engineer, or trying to fault find where a boiler may be going wrong. Right, so this is the general sequence of operation. I'm going to keep this simple because there are other components, sensors, things like that, which can come in between these main processes, but this is going to be your bog standard sequence of operation for the boiler. So first and foremost, we're looking for demand. So let's say that the boilers recognize a demand, whether that's for heating by turning the room stat up, or if it's a combi boiler, you've opened a hot tap to ask for hot water. So the boilers recognize a demand. First thing that it should go to next will be the pump. The pump should start kicking, it should start running. Now this pump may be within the boiler if it's a system or a combi boiler, or it may be an external pump if it's a heat only boiler, but there should be a pump somewhere in the system, and that will be the next thing to kick in. Right, after the pump, the boiler will then go to the fan. Now you should hear the fan coming on, you should hear it spinning, and it might ramp up to a certain speed, and then it will go to the gas valve. Now you may or may not have an air pressure switch in between here. Some boilers do, some boilers don't. I've only included the main components that every boiler will have in order for the sequence of operation. So once the fan's running, you should then hear the gas valve open. Now this might be like a clunk or something like that. You hear a little click or clunk, which will tell you that the gas valve is opening. Obviously you can test it with your U gauge, but that will be when you want to actually test the gas valve itself. Once the gas valve is open, you should then hear the electrodes sparking. And if they're sparking correctly and the gas valves are open correctly, you should then get ignition. So you should see flames within the burner or within the main heat exchanger. Now once the flames are lit, you should then get flame rectification. This is the final point in the sequence where the boilers recognize that the flame's lit, and it will stay on. So you'll maybe get a flame symbol come up on the boiler display, or it may just be a light which says burner on or anything like that. Just something to indicate that, yep, we're done, like the boiler's running now. So this is, like I said, a basic sequence of operation. These are all the components that you should find within a boiler. This is the basic sequence that I used when I started off doing breakdowns. I still use it today because every boiler is still going to run through this sequence. The only difference is you might have smaller individual components in between these processes that you may have to investigate, because obviously different boilers are built differently. Newer boilers have sensors, NTCs, overheat stats. Well, you get overheat stats on the older boilers anyway, but some of them didn't have certain sensors that the newer boilers will have these days. So you find that the newer boilers are a lot more sensitive to, say, differences in temperatures and things like that. So next time you guys go to a breakdown, follow this sequence and fire the boiler up and just see at what point is it stopping. And you can then work your way backwards and see, okay, let's say you get to the gas valve. So you put a demand on, the pump comes on, the fan kicks in, gas valve doesn't open. You can then investigate, is it going to be the gas valve? Is it going to be the fan to the gas valve? Could it be the PCB? Remember, the PCB is going to control all of these. So at any point in this sequence, if there is an issue, it could either be the component, or it could be the PCB not sending the voltage to the component in order for it to work. So you might find that you get to a fan which is not running. Now you might think, okay, that's a faulty fan, but it may be that the PCB is not actually sending the correct voltages to the fan in order for it to kick in. Or if you find that you got the voltage at the fan and the fan's not running, then you know that the PCB is sending the power to it, but it's the fan which is most likely to be at fault because it's not running even though it's got the correct voltage. So all I'm trying to say is, don't rule out just one component. Check it all back to the PCB and back to the component. Go through this process of elimination and then just work your way backwards to see at what point is your boiler failing to fire up, at what point is it failing in this sequence, and that should give you a better idea of where you need to investigate. So I hope that's helped you guys out a bit. Anyone who's starting off doing breakdowns, fault finding, if you need any more questions, drop a comment below or send me a DM. I'll try and help out as much as I can. But yeah, I hope you guys find this useful, and have a good Christmas and New Year's.